Hey, all, welcome to my channel. Earlier in one of my videos, I talked a little bit when I was describing between a data lake, delta lake, and a lake house. I kind of mentioned loosely about iceberg as well as Hudi. So it's one of those things where trying to define what they are is a benefactor to the fact that today's driven world, organizations are collecting information at an unprecedented rate. Of course, as I mentioned in my prior video, data lakes offer a flexible storage solution for this ever-growing data, but managing and analyzing it can be very challenging. That's where data lakehouses come into play, as I discussed in my prior video. Combining the storage capacity of data lakes with the structure and manageability of data warehouses. Now, Apache Hudi, as spelled Hudi, but pronounced as hoodie, like a hood, and Apache Iceberg are two of the most powerful open source table formats designed to revolutionize how you manage data into your data lakehouse. And it's come to the point where basically, with the lake house itself, these are two aspects. Now, the delta lake plays a big factor, but the one thing is with the delta lake, a delta or delta table is actually, it's a different format compared to what iceberg and Hudi are basically. So getting into it a little bit deeper, Apache Hudi now is one of those things is it's more of a case of like, it's short for Hadoop, upserts, deletes, and inserts. It's an open source table format that sits on top of your existing data lake storage like S3. It provides ACID compliance, ensuring data consistency even during real-time updates, deletes, and insertions. This makes Hudi a perfect fit for data pipelines that need to process and analyze data streams efficiently. Now you might ask us, like, why would you need this? If you're throwing into a data lake, why don't you do inserts? Well, the thing is, nowadays with these data warehouses, as you would like to call them, it's more of a case where or not data warehouses, but more of data lakes or data lakes with the engines themselves, like whether it be Snowflake, Synapse, Redshift, and GCP and others. The data resides in that data lake or lake house, but you're putting the tables on top of them. The one thing is though is they're mostly used for BI aspects, more for a traditional OLAP environment at that point. That's where your data warehousing comes to play. But now more and more, you're seeing to the aspect of a traditional data warehouse would be able to handle updates or upserts for that matter. And this is where these two frameworks or formats come into play, what helps out in that aspect, because a data lake, you're just pretty much appending data or files into the S3 bucket or whatever file storage you're doing and then reading off of that. But now more so to the point, like, you don't want to store that. You want to like have it as more of a case where making it a little bit more transactional, which comes to the aspect of making it a little bit more so of the aspect of the OLTP type environment. Now, it provides, of course, as I said, like Hudi provides that compliance for ACID compliance more than anything else, which ensures data consistency. And that's where the real-time updates and designs and deletes and such come into play at that part, as well as insertions. Now, insertions, it's not a real thing for that aspect, but the updates and deletes are the biggest factor itself, basically, more than anything else. And that's why for streaming data, this makes absolute the ideal world for Apache Hudi, and from that perspective, especially in the Hadoop world more than anything else. Now, some of the key features, of course, with Hudi is that it offers several key features that makes it a compelling choice for data lakehouse management. Unlike your traditional data lakes that only allow appending new data, as I mentioned, Hudi lets you modify existing records through upserts and deletes. This is crucial for real-time data pipelines where data is constantly changing. Additionally, Hudi excels at like handling rapidly incoming data streams, where it enables essentially like your near real-time analytics. Hudi is also Hudi boasts a flexible architecture or schema or architecture more than anything else, or schema evolution, allowing you to adapt your data structure without having to disrupt your existing workflows. And think of it this way: Parquet formats, Parquet files more than anything else. That's pretty much what it comes down to. But quite honestly, it's a different file format that falls into that aspect because Parquet doesn't really handle well with upserts whereas Hudi does. So think of it in that as a column store that you can handle for upserts. And the other aspect as well is with Hudi, which is a big factor now, especially the fact with change data capture that you're seeing, and especially features that you're seeing in other data warehouse engines, SQL, Snowflake, Synapse, Redshift, is this time travel functionality, as well as Oracle. I should say Oracle too. I can't deny Oracle. So Hudi does have this time travel functionality where it lets you analyze historical data, providing you the valuable insights into trends and changes over time. Now, some of the use cases for Hudi basically, some of the use cases for Hudi capabilities make it valuable tool for various use cases. In the financial sector, Hudi can be used for real-time fraud detection by analyzing transactions as they occur. Similarly, server logs can be efficiently ingested and updated for real-time insights. Hudi also shines from a perspective of personalizing recommendations by allowing dynamic updates to user profiles. The ever-flowing stream of sensor data from, like, let's say, IoT devices, which are becoming much more and more mainstream more than anything else nowadays. And when I'm saying IoT devices, nowadays you're thinking like those smart speakers you have, like the Alexas and Google Homes, and your mobile devices for that matter are becoming known as IoT devices. Anything that's internet enabled, essentially, that's not your traditional laptop, not your traditional desktop, etc., or tablets for that matter, but smart appliances more than anything else. They can be managed effectively with Hudi's ability to handle updates efficiently. Hudi is also useful for master data management, or MDM for short. It ensures consistent master data records, building data warehouses that can handle updates and corrections, which becomes easier with Hudi. Now, from this aspect, you always will have to make certain updates at that point, because when it comes to data validation and data quality, this is where it comes into play for that master data management. It has to play into that factor. Finally, of course, Hudi facilitates change data capture, which is, of course, in this case, similar to what time travel is, by seamlessly integrating, changes from operational databases into your data lakehouse. Now, what is Iceberg, which I've talked about earlier, basically, as well? This is the other aspect of another file format, too. So now, Apache Iceberg is just another open source table format designed for data lakes. Unlike Hudi's focus on real-time updates, Iceberg excels at providing a high-performance, scalable metadata layer for your data lake, similar to what the Delta Lake is. Put it this way, when Databricks came out with their Delta Lake, Iceberg came up from that same aspect, but it was more metadata driven for these high performance, so that you could do these high performance updates. This robust metadata layer enables efficient querying and data management, making it ideal for organizations working with massive data sets. Like Hudi, Iceberg guarantees data consistency through ACID transactions and ensuring the integrity of your data during all operations. Now, key features of Iceberg, where it boasts, Iceberg boasts several key features, put it that way. That makes it a strong contender for data lakehouse management. When dealing with vast amounts of data, Iceberg shines with exceptional scalability, allowing you to efficiently query and manage massive data sets. Like Hudi, I guess, Iceberg upholds data integrity through the ACID transactions. Iceberg allows you for schema evolution, and you can adapt your data structure without disrupting those existing workflows like Hudi. And also, finally, of course, Iceberg does support, like Hudi, time travel capabilities to let you explore historical data versions, providing valuable context for understanding trends and changes over time. It's really useful from that perspective. Iceberg's strengths make it a valuable asset for various data lakehouse use cases. Large-scale data analytics become more manageable with Iceberg's optimized queries and efficient data access. You can build data warehouses on top of the data lake, which becomes more feasible with Iceberg's robust table format. I wish I could show you an Iceberg format, but I don't have access to an Azure environment or AWS environment right now because I've already exceeded my credit limit, so I don't want to really apply that. But when you're dealing with vast amount of log data, which is a big example. Iceberg facilitates efficient management and analysis. Iceberg also simplifies data sharing collaboration by providing a standardized metadata layer, similar to what you were seeing with a Delta Lake. Now, machine learning pipelines benefit from Iceberg's ability to keep data clean and organized, to the point where, put it this way, when you're applying your as you're adding new features to the machine learning models, you want that data to be clean. The problem is like if that data is not clean or there's no data validation, then you have issues at that point. So it's one of those things where this part of Iceberg actually makes it a little bit more easier to do the data cleansing and keeping it cleaned, and also keeping a record of it, but being organized, sort of to the point where like it's on a curated layer more than anything else. Now, real-time business intelligence dashboards also play a big factor that could read into this, and it can be powered by Iceberg's efficient data retrieval capabilities. Finally, of course, Iceberg's strong metadata management helps you to maintain data governance, which is a big thing, as well as I mentioned, data quality within your data lakehouse. Now, data governance is a factor that's now becoming more and more predominant in this data world, to the point where if you don't have at least the base models of your data governance in place, or data governance principles in place, the base aspects of it, it's a recipe for data essentially being applicable or accessible by anyone or any person basically at that point. Now, of course, so far we've explored the capabilities of both Hudi and Iceberg. Now, let's compare them to head-to-head to which one might be a benefit for your needs. More in case, some of the features or focus areas that will be applied with Hudi over Iceberg is that, Hudi supports real-time updates for asset transaction schema evolution, whereas Iceberg, its scalability, high-performance querying, and asset transaction with schema evolution. The key differences between, of course, lies in their primary focus area, where Hudi excels in real-time data pipelines, whereas data is constantly changing. Its ability to handle upsearch, deletes, and inserts efficiently makes it ideal for other scenarios, whereas Hudi also guarantees data consistency through asset transaction and allows for schema evolution without data rewrites, which in the data world, more so to the aspect of data engineering world, it's something that some people love to apply from that part. Whereas Iceberg, on the other hand, it shines when you're dealing with massive data sets, and it focuses on scalability, ensures efficient querying and data management even for vast amounts of information. Similar to Hudi, Iceberg offers asset transaction and schema evolution to data integrity and flexibility. Now, the strengths of Hudi, it boasts several strengths that make it a compelling choice for specific use cases. The ability to handle real-time updates efficiently positions Hudi as a front runner for data pipelines that could continuously ingest and process streaming data. Hudi allows for also schema evolution, giving you the flexibility to adapt your data structure as needed without disrupting existing workflows. Finally, of course, Hudi's time travel functionality provides, that valuable insights by enabling you to analyze historical versions of your data. Now, Iceberg, some of the strengths of data Iceberg also offers several strengths that makes it a valuable asset for data and lakehouses. When dealing with various amounts of data, Iceberg's exceptional scalability ensures efficient querying and data management. Sharing and collaborating is something where the data becomes much more easier, and it's sort of on Iceberg's standardized metadata layer, and that's where it becomes easier, and it allows you to foster more of a collaborative data environment. Think of such as aspects of the fact that it's shared across. Now you can create tables on top of it, and of course, with Iceberg itself as well too, it has a robust metadata management feature which empowers, as I mentioned earlier, data governance initiatives and ensures that data quality that you need within your data lakehouse. Now, when it comes to choosing between Hudi and Iceberg, it depends on your specific needs. If real-time data pipelines are priority, Hudi is your clear choice. If you need those, real-time data pipelines. For large-scale data analytics, Iceberg excels far more over Hudi at that point, but Hudi remains still a viable option from that perspective. If real-time updates also are a factor from that perspective. Now, compatibility with your existing data lake ecosystem is also something that you can't take for granted, and also adds a big factor, making it an important factor. And then the other aspect as well is you got to consider data governance. I mean, like I said, data governance is becoming a big thing. You have to know what some of the requirements are for them, because like both Hudi and Iceberg offer data governance features, but Iceberg's strong metadata management might make it, well, it makes it much more suitable choice for stricter governance needs. Now, oops, I'm trying to switch off to this. Now with Hudi, Iceberg, and our powerful open table, basically, Hudi and Iceberg are powerful open source table formats for data lakehouses. That compared to the Delta Lake or Delta tables. Choosing Hudi for real-time data pipelines and schema evolution, choosing Iceberg for large-scale data analytics, data sharing, and data governance. Both tools can potentially work together. However, one of the aspects is when comparing that to the Delta tables or Delta Lake with Databricks, it's one of those things where Spark becomes a bigger factor. That's the one thing with Delta Lake is in Delta Lakes, specifically in Databricks, Spark and Spark SQL are the one ideal that works from that perspective. That's why some people were looking for Iceberg or Hudi because they needed to go outside of that, supporting of the Delta table framework with Spark. But from that perspective, if I had a choice to choose between, depending on your use case, again, if you have large, massively data sets where you need governance, Iceberg plays a huge factor, and that's a big thing. But then there's the Delta Lake as well too. So you can't not take that into account because it does apply into this. Which one's the better one? I think that's where it's up to you based on your use case. If you're doing a lot of machine learning, I would say probably you might want to go the Delta Lake route more than anything else. But Iceberg is relatively new. It's slowly being incorporated into a lot of the data warehousing engines. So you might want to take a look into that and do a comparison and see. Doing a quick POC doesn't hurt from that aspect. But I believe, honestly, it's up to you, the user, based on your use case, based on your needs, to choose the right one that best fits your need. Now, will you see other engines using Hudi? Because like Hudi is really used in the Hadoop world with the Hadoop framework. So, of course, there's Spark and MapReduce, but more so Hive comes from that perspective, as well as Impala and I want to say Presto. But it's a case where, like, again, I think Hudi will slowly pushed away to the point where it comes down to Iceberg versus Delta. And between those two, I think it's going to come down to that unless a new framework comes into play. And let's not forget, Google is probably going to jump into this very quickly and add their own format. And then it's going to change the dynamics of the whole lakehouse completely at that point. But it's a matter of how it's being defined for those use cases. But outside of that, I'll just leave it at that. Let me know your thoughts. If you have any questions, I know I didn't give you the specific details. I would love to have shown you some of the stuff on Azure or AWS for that matter, one of those two. But unfortunately, I ran out of credits, unfortunately. And I'm not willing to put up my credit card because I'm not doing this for the sake of, basically. Unless one of them is willing to sponsor me, quite honestly. But outside of that, I'm not willing to do that. But I'll probably try to create some graphics and show you from that perspective. And maybe, there might be some other YouTube videos out there that will show it more specific. That would be more in depth. But outside of that, I'm hoping this helped you to understand the difference between Apache Hudi versus Apache Iceberg, what the benefits are, why you might use one over the other, as well as whether you want to use the Delta Lake based on the prior video, between a data lake house, and Delta Lake, basically. Hopefully, this expands a little bit more and helps you choosing the right path, and also giving you the ability to understand basically what what it is from this perspective of what Hudi and such are. Outside of that, I mean, as a data enthusiast, if you're a data enthusiast like you, I hope you enjoy my video. With that, I'll leave it at that. Until next time.